Hello everyone, thank you for joining us. And we definitely hear a lot of talk about AI agents recently, and we are here to see together with you live if AI agents can indeed walk the walk when it comes to vulnerability remediation. My name is Mauro Goldberg and I'm joined with Eran Leib. We're both co-founders of Backline and we're really happy to be here. We will talk a little bit about AI agents, what is vulnerability remediation, how AI agents can help us in cybersecurity overall and remediation in particular. The main part is Eran taking you through a live demo of remediation. I will say that some of it is CLI based, so for the people who are sitting in the back, there's more room in the front if you want to see it better, but hopefully it will be fine. And then eventually we'll talk a little bit about Backline and what do we do and how can we address vulnerability remediation at scale with AI agents. So we started Backline because I'm assuming, much like many of you here, we saw how security teams keep buying more and more great and awesome tools that predominantly find problems for other teams to fix. We buy application security and cloud security and so forth and so on, and all of these tools, without an exception, find problems for other teams in the organization to fix. All of these teams, almost always, don't have enough time to fix all of these vulnerabilities, and we keep seeing how backlogs keep growing and growing, and the answer that we have is prioritization, right? We know that you cannot address your hundreds of thousands of vulnerabilities, but we help you figure out what's your top 10 or top 50, but the backlogs just keep growing. When you look at security backlog and these backlogs in the security tools and in our JIRAs and so forth and so on, the reality is that most of them can be fixed, but we just don't have the bandwidth to fix it. AI agents are exciting, and we hear a lot of talk about AI agents and how they can help us in different areas in our lives, and we were very intrigued with AI agents, having been cybersecurity practitioner for so many years, and we asked ourselves, can AI agents really help us address some of the most daunting, painful tasks that we need to do today when it comes to vulnerability remediation? We already saw, right, how agents can help us in investigation when it comes to our security operations center. We saw how agents can help us address some of the security practitioners' day-to-day tasks that we are doing, but we asked ourselves, can we bring the same capabilities and the same exciting capabilities of AI agents that we see to remediation? And so we are here today to test together with you, can AI agents actually solve vulnerability remediation? And Eran will take you through the demo.
Thank you. So good afternoon, everyone. So my name is Eran Leib. I'm one of the co-founders of Backline. And what we're going to see today is basically the evolution of AI agents in the last year, and then we're going to see how Backline actually looks like and what can we solve with that. So starting with the first thing that I want to show is actually what is a finding that we're talking about. So a finding here in this case is something that coming from Security Hub. You can see the highlighted in red. It's a CVE coming from Snyk into Security Hub, talking about a CVE in Lodash in one of our applications. And let's see how does that look like and what would we do if we go back in time 12 months, what would you have to do to solve this? So 12 months ago, I would get this and I would get my manager, security manager, telling me you have to solve this CVE, and I will have to go and do it manually. Manual work here is quite tedious. As we can see, I would have to go and install the upgraded package. This upgraded package is something that I got from the scanner. This is the recommendation. It's not necessarily the right package. It's the minimum package that solves that issue. It's not necessarily the one that will be the best fit for my solution. So what will happen here is I will install and then I will try to build my application. Once I do that, I get a ton of issues because there are a lot of breaking changes. I'm upgrading here from 3.10 to 4.17.2. There are a lot of breaking changes, and now I need to have to go and start investigating one after the other the different functions that are failing, deprecated, changed, and I need to find out how do I solve all of these breaking changes. It's a mess. It's not simple, it's hard. So the first thing that I had to solve was investigation. Fast forward 3 months, came all of the chats, the LLM chats. I chose Claude here for the demo, and what we can see that Claude actually solved for me is that the first thing that I'm going to do is I'm going to tell it, I have this CVE, how do I resolve that? And what Claude does is it gives me all the analysis. It will show me the issues around that CV that is happening, and it will tell me all the different steps that I did manually before, which ones do I need to follow. But it's not enough, because there is another step that I need to do here. As we saw, there are a lot of breaking changes. So I can ask Claude, give me some more data. Help me here to solve these breaking changes. And Claude will actually go and try to help me. It will find all the breaking changes that exist between these two packages, because I gave it my existing package and what's the one I'm going to. And we'll go through the different places that these breaking changes happen. Again, doesn't have the context of my app. It knows just which package I have and which package I'm going to. And now I need to do, again, all the legwork of actually fixing these issues. So this is really, if you think about it, really the pinnacle of where we were 9 months ago. If you think about it, with Claude, with all the data that I get from here, it would still take me between a week to 2 weeks on a medium to large application to solve one CVE, okay, just one CVE. So, and again, a lot of data that we get here, as you can see here, the timeline estimate that Claude gives you is quite long. The next step is, again, 3 months forward. We had Claude, but we also had IDEs that will help me to facilitate this fix. So not just the knowledge, but also having the context of the application itself. And what happens here is we basically married the two of them. So we're getting, in this case, cursor, and I have the specifically Claude loaded up here. And Claude tells me, here you go, upgrade to this version. I will do that. But if you notice one thing that happens here, I have to walk cursor hand by hand, like every step of the way. Okay, I build the application. Do you want to build it? Yes. Oh, there are a lot of breaking changes. Do you want me to fix them? Yes, I want you to do all that. It will try to fix each and every one of them. But again, it's like a child. You have to walk it through the process, and it cannot do everything on its own. And yes, it will miss things at the end. It's not perfect, and it's not very accurate. It's good for, I would say, non-production cases in this story. And you can see that, like in this case, after fixing each and every one of these issues, at the end it will actually miss one of the issues. So it will still not build at the end after everything that I've done. So you see, still a missing one. So fast forward for 3 months ago and today, let's unleash the agents. And what I'm going to show you right now is a demo of the Backline CLI that is actually working with a team of agents, AI agents that are working in coordination. Think about it as a security team, an engineering team, platform team, dev team that is working all together to solve this problem. And what we will see here is the agents starting to talk and basically say, okay, I want you to solve this issue. And they start taking one after the other, all these steps that we saw, but in a way more accurate way, because each of them is doing a separate job. So again, removing hallucinations and bias, and each of them is walking through the different steps in the process. So the first one that we have here, the security analyst that is looking on the finding, it will bring all the context for the application, so I will know exactly where do I need to fix something, or where do they need to fix something, and how are they going to fix it, because they know exactly all the context. The second thing that we see here is the remediation planner is drawing a new remediation plan specifically for my application. It's not for something general, it's not a recommendation, it's looking at my specific context with my specific code and telling me, okay, these are the breaking changes that are going to happen here, and this is how you're going to fix it. It's not me, it's him. And then eventually the coder here is actually going to step into the shoes of the developer and apply all of these changes into the mix. And the last step here is going to be opening up a pull request that we're going to see in just a second. So the pull request that we see here is actually quite elaborate, way better than what you would see from a human developer, to be honest. What we see here is, first of all, we can see that we have this, again, this is the Lodash package. We can see that we got here a vulnerability that was identified from Snyk. We can see the CVE here, and we can see all the other CVEs that are going to be resolved as results from the agents to actually fix this. To provide full transparency, you have here the complete remediation plan that the agents are going to execute on. And if we go to the actual code, we can see all the different steps that the agents actually did. So this is, again, the first step, but they also had a reflection loop. So they started fixing something, and then they had issues. So they found the remediation plan here to fix, like the deprecation of functions, changes of functions. Some things were in the beginning and they don't exist now. Some of them were changed. You can see here, for example, something which is quite hard for a developer even to find, like the initiator, the constructors for this function was even gone. So now you have to change the whole way that you do it. You have a function that it used to exist and now doesn't exist, and now you have to concatenate two different functions to actually achieve the same result at the end. It's pretty impressive for the agent to do all that on its own. And eventually this is super accurate. Last but not least, the agents also handle coverage in terms of tests. So, for example, in this case, we're leveraging the set of tests of the unit tests that this application has. But we discovered that one of the areas are missing some tests. So we added the relevant tests to the package so we can actually integrate completely into the CI.
We've founded Backline because we saw time after time again large and medium organizations just drowning in security problems. And we founded Backline because we saw what we can do with AI in a belief that we can automate the vast majority of vulnerabilities, automate the remediation, the vast majority of vulnerabilities that organizations are facing today. We're not saying that we will solve 100% of the vulnerabilities and 100% of the time, but we know already, and we see it with our early adopters, with our customers in the lab, that we can resolve the vast majority completely autonomously. And when we say something needs to be handled by engineers, it's because something actually needs to be handled by human engineers, and our AI agents can reach out to engineers, to code owners, and so forth and so on, to complete the work when a human engineer help is needed. Working with large organizations for so many years, we knew from the get-go that the challenge is going to be about accuracy and trust. We're all using the different ChatGPTs out there, and we know that there are inherent problems with large language models. All of our technology is around accuracy and safety of deploying AI agents in large, complicated enterprise environment. It starts with our own AI native remediation playbooks. It's cool to give instructions in English, but with AI agents, it works much better when you have your own technology in your own specific way to provide instructions to the AI agent on how to remediate an issue. Eran talked about testing and verification, so it's not just about, hey, here's an idea, here's a fix. We're actually testing and verifying that the fixes are safe to be introduced to a specific customer environment. So again, everything that we are doing is about trust, accuracy, and safety of deploying AI for remediation use case in a large enterprise environment. We're starting by ingesting common vulnerabilities into our security finding lake, which is an inventory of all of your security problems. Our AI agents will be deployed against the security finding lakes, and step by step, much like Eran showed you, and we'll show you in a demo in a second, we'll analyze, understand what is the issue, what's the best way to fix the issue in the customer-specific environment. Everything that we collect in terms of context is designed to guide the agents to operate in a specific customer environment and to improve the accuracy and the results. The remediation planner will plan what needs to be done. It will go to a software engineer agent that will actually do all the code changes that Eran just shared with you, and that will eventually go to a quality engineer agent that will test and verify that whatever fix that we are proposing is actually safe, not going to break your application, break your workload, and so forth and so on. When all of this is set and done, as Eran just demoed, we will open a pull request that the human engineer can still review. Our goal is definitely to get to a point where the vast majority of these pull requests will be automatically merged in environments in the future. With that, we have a couple of more minutes, so we wanted to show you an actual live demo of the product.
So what we saw in the CLI was handling a single CV. But what we wanted to do here is to scale it up to be able to handle an enterprise. So as Maor showed, we're starting by getting all your data, all your findings into the security findings lake. So we have the different connectors that you can use. And then all of these findings are gathered here, and you can see the atoms. Okay, the basic unit of discussion here is a finding. We can see these findings are coming from GitHub Advanced Security, they come from Snyk, Wiz, etc. And if we click on one of them, we can see the details that we see on them. So we can see the data that is coming from the original scanner, but also data that we enrich on top of that. For example, like if there is a remediation that is already associated with it, you'll see it here. If there are findings that are related to this because they're duplicate, because they're going to be resolved together with that, then you can see it here as well. And of course, there's an SLA here. We allow you to configure your SLA according to whatever your company policy is. Moving from that, we can actually go to the remediation. This is actually the meat and potatoes, and we can see here the different remediations. So if a finding is the base unit, remediation is a grouping of everything that is going to fall under that plan. Once that plan is deployed, that remediation is going to solve the group of findings. What we can see here, if we scroll through a bit, we can see different types of remediations. We can see autonomous that Mor was talking about. We can see manual, we can see hybrid, where you have to actually have the agents are asking for you to intervene. If we'll go and look at one of these, we can see here a few interesting things. One, of course, there's priorities that you can configure. You can see the findings that are, again, going to be resolved within this remediation. In each of them, you have a Jira ticket, in this case, that was associated. So we actually, because we're stepping into the shoes of developers and engineers, we can actually associate these Jira tickets together with the finding. And if we have, if we're going to solve it, we're going to close the tickets and we're going to collate them together. Mor was talking about trust and safety. One of the main things here is transparency. Our agents don't hide what they're doing. They're actually very front and center telling you what they're doing. So everything here is completely transparent. You can see the complete plan, what they're actually doing every step of the way. And actually, I think one of the coolest things you can see here is the agents talking between each other, how they actually work together. So it's really a team. You can see the planner working here to work with the analyzer, the worker, and then the coder starts to work, and they actually start deploying the fixes. Because we're developers by profession, we know that developers are not going to be here. But on the other hand, we know that security teams are not going to go into GitHub. So to each his own. The GitHub that we saw before is something that the engineers will go to, and this is the place where we expect security teams to go and see all this data. And last but not least, of course, a dashboard to give you a bird's eye view on everything that we have here. You can see, I think my connection here is a bit dead.
The gods of the demos.
Yeah, the demo gods. So we can see here the details that we can see on like our remediation velocity, for example, or the types of remediation that we have. So for example, let's say that I have here remediations that are coming from findings that are coming from Security Hub. We can see how they split by autonomous, hybrid, and manual. We can see the remediation status for each of those. For each of the findings, again, bird's eye view to understand the metrics of how your mean time to remediation between the different types of operation.
The goal is definitely, in the end of the day, is to see all of your findings, if you can scroll up a tiny bit around, all of your findings from your different scanners, which were not there to replace, how they are ingested into our system, and that the vast majority of them are being handled completely autonomously by the AI agents. And of course, we realize, as I said earlier, that in some cases, there will be human involved, and you will be able to track not just the autonomous efforts, but also the hybrid and the manual efforts as well. We don't add more prioritization process in our system, but we do take your SLA into consideration, so we know when to deploy the agents to make sure that we help you meet your SLAs when you have 90 days or 30 days to fix a critical vulnerability. So that's something we definitely take into consideration.
I would even add that the agents want to go into the autonomous mode. So even if they're on hybrid, they are learning from what the actions that you're taking, and then they can take it to the next step.
So we're almost out of time. Thank you very much for joining us today. We are right behind the Zafran booth over there, so if you want to turn around and take a quick look, we are there for the rest of the day, and happy to answer any other questions that you might have. Thank you.